All right. And thank you. And if you do happen to see someone come in after, after a few minutes, please ask them to, if you think of it, ask them to put their name and campus. So thank you for doing that. All right. So I have a set that I've actually I don't think I've ever worked through on a review session, and that's an additional practice set that I put together. And then I also had some other questions that were sent to me via YouTube for, I think they are at Boyce or North, and not Allegheny campus, but the questions are relative because it's more on the flow rate stuff, which is the new stuff, which my guess is that's the one to kind of to focus on. So that's what we're going to start with. And then as we're going through, if you have a question while I'm working through a problem, you can go ahead and unmute and ask. Or if you have a question and I'm not working on and you want me to work through one of the review questions, just type in, your question on the in the chat. That way I can see it and I will address it. All right. So first things first, I just want to go through these review problems just as extra practice. So if you are at North, Boyce, or South, remember a lot of your questions are just going to say how much medication would you administer in one dose. Okay, so it's not going to, you're going to need to know how to find or you're going to need to know that you're looking for a particular medication, meaning or a particular, you need to make sure you're writing your units. Okay, now when there's a question like this and it specifically asks you to look for teaspoons, okay, I imagine that would be given to you. Otherwise, you would just solve for milliliters. So this question is repeated. It's on the practice tests, but as a reminder, when you're doing this, there's two ways you can do this. You can do, ordered over half. That works just fine. Or you can do dimensional analysis. So I want to show you just a couple of ways. So I'll show you the long way. So if you want to see the conversions that were added, they're actually on where it says 23 spring. If you open up that folder or that document, you'll see where they're still on there. But if you're Allegheny campus, you don't need to worry about cups, quarts, pints. That's not something you need to worry about right now. But I will I'll go back. I'll most likely go back to that because it won't take me long to go through these. You're welcome. Okay, so with teaspoons, or with this, first of all, you want to pay attention to what your order is, 400 milligrams. That is by mouth. The by mouth tells you it's a tablet, capsule, or milliliter. And the reason I'm saying that is for those of you not at Allegheny campus, you need to know what you're converting to. And so if you ever get stuck, just remember, okay, well, what kinds of medications can be delivered by mouth? Pretty much everything, right? But if we're talking about intramuscular, intravenous, or subcutaneous, those are always going to be liquids, and it's always going to be milliliters is what you're looking for. And when I say always, that's the always except when you're dealing with like a drop rate or something like that. But anyways, so we look at our label. It says 125.5. So someone's asking about these. What I'm showing you right now is already available to you. You just go to the shared OneDrive folder and you can see what I do. I would don't open it while we're on it, unless you can, but you're going to see me marking as we're going through it. So just I should have maybe don't open the 23 spring one. Just open the blank one, the one that says 23 spring, I have open and I'm writing on, so it will change. And if you start writing on it too, it will get recorded. So, but it's available to you. All right. So let's do this dimensional analysis wise. I'm going to start with my 400 milligrams. I'm going to convert my milligrams first to milliliters. So I'm going to show you the long way just because I think North, South, and Boyce benefit from seeing the long dimensional analysis. That's just something you end up doing. So if you need to see this way. All right. So this is 5 ml. This is 125 milligrams. And then we're also converting this to teaspoons, and I'll show you another shortcut. Okay. So you do need to know your conversion from milliliters to teaspoons. And 1 teaspoon is 5 ml. Okay. You work this through, and you're going to come up with an answer of 400 divided by 125. And you're actually going to get a decimal answer for this is 3.2 teaspoons. And you may be wondering, like, why didn't I mention anything about fives? Well, they cancel out, right? Okay, milliliters cancels out, milligrams cancels out, and we're left with just teaspoons. Another shortcut is, since you already know that 1 teaspoon is 5 ml, you can actually make that conversion right here, where you could say 400 milligrams times 1 teaspoon over 125 milligrams. That will work out the same way. And if you're doing ordered over half, 400 over 125 is the correct way to do that. Times 1 teaspoon or times 5 ml, and then convert to teaspoons. All right. 2 Bex questions. A lot of times the main reason these 2 Bex questions get missed is because, so I would say for these problems, that's a good question, Alex. No, do not round your answer. Okay. My guess is that if you're at one of the other campuses, it's going to stop at milliliters. But if you are at Allegheny campus, technically, if you have the right type of syringe, you can probably administer 3.2 teaspoons. The only thing you wouldn't round that's like a liquid would be drops, but you can round those to the nearest tenth. Yeah, so somebody's asking about the practice test. So where you got the link to join this Zoom, it says click here for practice tests, and that's the link. And if you don't have that link, just remind me at the end, and I'll make sure I'll email you, or I'll give you my email address. Just remind me. All right, so for this question, pretty straightforward. So if you're at one of the other campuses, it might just say you will give, how much medication will you give in 1 dose? You need to know it's milliliters. How do you know it's milliliters? 2 reasons. It says on the label, and it's intramuscular. It's intramuscular, it's milliliters. Okay. Where this commonly gets wrong is people just forget to mark the 2 Bex. Okay. But you're just going to do, and this is one you can just do order over half, 40 divided by 50. We'll give you 0.8 as your answer. And then you need to just make sure that you mark the correct portion of the 2 Bex. So this is 0.5, 0.6, 0.7, 0.8. So you just mark the 2 Bex. I'm not exactly sure, because this is not like marking a syringe. So I don't think you would shade this whole area. But if they tell you to, then you would just shade this whole area. Heparin question, similar format. Again, if you're at North, South, or Boyce, it might just say how much would you deliver in one dose. You would look at the label. The label tells you 10,000 units per ml. Your order is the 8,000 units. Subcutaneous tells you it's milliliters. So even if it's not given to you, you should be able to figure that out. And then you're just going to take your 8,000 units. And again, if you're doing this ordered over half, which is perfectly fine for these, over 10,000 units times the 1 mil. And you're going to get the same answer as you did above, 0.8 milliliters. Okay. And then you would just mark it at the 0.8. Now, the thing you want to pay attention to when you're marking a 2 Bex or even syringes is sometimes the increments are in 2s, meaning like 2, 4, 6, 8. So just pay attention. I usually see the by 2s on like an insulin syringe. So just pay attention. Some of the syringes are a little bit different. So if it does ask you to mark the syringe or, you know, and if it's, just pay attention to how it's labeled. Don't just guess. All right, so let's get into some of these again, because these are just some additional practice. Again, I work through these on Tuesday, so you can watch the original review, but I'll remind you of a couple things. First of all, again, if you're at Allegheny or I'm sorry, North Boyce to South, it might just say what is the flow rate and not tell you drops per minute. Okay, so how do you know you're dealing with drops then? Well, it gave you a macro tubing drop factor of 10 drops per milliliter. So that's your indication. Okay. If they just ask for what is the rate or what is the flow rate or what would you set the infusion to, and even equally confusing is what is the drip rate, because drip rate can also be just regular flow rate, milliliters per hour, or it could be drop rate, like drops per minute. So just pay attention. The context of the question should tell you what you're dealing with. There is, I don't have a specific 130 practice test for Boyce. But I do know what's on your blueprint, which is why I know how your questions are asked. So I've done more review type work with 230 at Boyce. And then there's, if you go to the OneDrive folder, if you go to the Boyce folder and 230, and then I think there's some 110 stuff too, you can see some of the practice stuff that I put together that's specific for Boyce. But like I said, Boyce North and South are kind of very similar. Allegheny is just a little bit different in that Allegheny seems to get a little bit more information as far as what they're looking for. All right. But it all boils down to knowing how to do this in general, because when you get on the NCLEX, you don't, who knows how they're going to, set that up. So, all right. Just want to double check some things here. We're good. All right. So for this question, there's something you need to keep in mind. So dimensional analysis is what I utilize when I do this. If you ever get stuck and you're like, well, where do I start? I always recommend starting with flow rate. Okay. Start with your flow rate, multiply by your drop factor, and that will give you your drop rate. So what was my flow rate? Well, my flow rate says 180 milliliters in 2 hours. So I'm going to do this long way. Okay. So that's perfectly fine. 180 milliliters, 2 hours. So that's your flow rate. And then I want to correlate that with the drop factor. So I'm just going, like I said, I'm going to do this the long dimensional analysis way, and then I'll show you the kind of the condensed version of this. I just want to move my cursor. So I'm going to multiply by my drop factor. And what's telling me to do that is because I know I'm looking for drops, right? And I know I'm looking to get rid of milliliters. So we're almost there. The next step is I need to convert hours to minutes. And that's usually pretty straightforward, right? So we know that 1 hour is equivalent to 60 minutes. So a lot of times when you guys see on your blueprint where it says like a complex problem, it just means it requires more than one step. So I'm showing you the kind of extrapolated dimensional analysis way of doing this. The benefit, again, if you've not worked with me before, of doing dimensional analysis is you can see what units are being eliminated and you can see what you're left with. So before you do any kind of math, you've at least got the arrangement correct, right? So if we're dealing with drop factors, you need to know drops per minute, or if you're at Allegheny campus, it'll tell you drops per minute. And then we're just going to plug these values into our calculator. So 180 times 10 divided by 2 divided by 60. And I'm going to get an answer of 15 drops per minute. If I was trying to condense this, I would sit there and I'd write this like this. I'd take the 180 milliliters. 2 hours is the same thing as what? 120 minutes, right? then I would multiply by my drop factor. And the reason I would do it this way is just because it saves a step, right? I don't have that third conversion because I just did it here and I just put it into the problem. It's kind of the same thing if for you guys at North, South, and Boyce, if it's 1 cup and you already know it's 240 milliliters, you just put that right into your equation. You don't have to say 1 cup and then is 8 ounces is 240 milliliters. You don't have to go through that process if you already know what the end result is. Anyways. And I mentioned this last time too. The only time that that you might get like a micro or a drop factor question and then it doesn't give you or give you a drop rate question, it doesn't give you the drop factor, it'll say that they used microtubing. And if they say they used microtubing, if you recall, that means that your drop factor is 60 drops per milliliter. That's for microtubing. Your macrotubing can be any number. I've seen 5, 10, 15, 20. I've seen a variety of numbers, as I'm sure you have as well. And I imagine they're used for different types of medications. All right. What about just flow rate? Now, this is, believe it or not, a commonly missed type of question where we're just asking you to calculate the flow rate. And again, at Allegheny campus, they're going to know. Okay, so someone asked, would it be correct to define drop factor as drop rate divided by flow rate? No, the drop factor is given to you. You could work it backwards to find out the drop factor, but I don't think that anyone's going to ask you to calculate the drop factor. They want to know rates. So I would say maybe, but I would focus more on flow rate times drop factor equaling drop rate, or just doing the dimensional analysis to solve these types of questions. That's my recommendation, at least. All right. So with these questions, first of all, let's say you're at North, South, or Boyce, and it just says calculate the flow rate, doesn't tell you milliliters per hour. How do you know you're doing milliliters per hour? Oh, okay. Yeah. So the drop factor is what the manufacturer of the tubing has defined as the equivalent for the number of drops that come out. So that's what the drop factor is. So like if you that way it's precise, right? So I want to know how many drops make up a milliliter. So is it 8 drops? Is it 100 drops? Is it 2 drops? That's what the drop factor is. So the manufacturer has done those specifications to get it to be, okay, 15 drops is 1 milliliter. 100 drops is 1 milliliter, or whatever the case may be. 60 drops is 1 milliliter. So you can see that if it's more drops per milliliter, that means the tubing is very small. And then the bigger the tubing, the more or the fewer drops to make a milliliter. So that's what a drop factor is. Yep, drops in a milliliter. Exactly right. All right. So for this, when we're calculating flow rate, you don't necessarily need to do much dimensional analysis, but you need to know how to reduce or convert. So I guess if I'm being a purist, then yes, dimensional analysis works perfectly for this. So again, how do you know on this question, how do I know I'm calculating flow rate in milliliters per hour versus drops per minute? Notice that it doesn't say anything about any kind of tubing. It doesn't say microtubing, doesn't give me a drop factor. So if it doesn't give me any of that information, I know that I need to convert milliliters per minute to milliliters per hour. So I'm going to take my 300 milliliters divided by 75 minutes. Then I'm going to convert minutes. So I know that there's 60 minutes in 1 hour. Then I just take 60 times 300 divided by 75. And I get 240 milliliters per hour. Another common thing that will trip students up is it'll tell you that you have 100 grams of Ensure in 300 milliliters, or 500 grams of Ensure in 300 milliliters. When we're talking about flow rates, we don't care about the strength. We care about the strength as far as the application and giving it to the patient, but as far as calculating how fast it's flowing, we do not care about the strength of the medication. So whether you see and you'll see practice questions where it has like Solumedrol as a good example, and Solumedrol, 120 milligrams Solumedrol in 250 ml to infuse over 25 minutes, calculate the flow rate. All you care about is the ml and the time. Okay. All right, so this is another one of those questions where you have time in place. So you may see some of these practice questions. Remember that when we talk about time, especially if it asks you, so this is just ask you how long it will take in hours and minutes. But if you're doing, if it told you it started at Monday at 10 a.m., when will it end? Then you need to make sure you're using military time, and then make sure you're indicating what day and time it would end. So if it's only a 2-hour run, then it started at Monday at 1000 hours, and then it ended on Monday at 1200 hours, right? So that's how you would set that up. All right. So for this one, I'm going to arrange this a little bit differently, but again, I'm going to utilize dimensional analysis as my strategy here. What I'm looking for is how much time okay. And what I'm going to see is, and if you do this, this is what you're going to get, and this is not going to help you out. So 500 divided by 200 will give you, actually, it's fine. It'll give you 2.5 hours. Okay. And then you would convert that, because it asks you how many hours and minutes, to 2 hours, 30 minutes. But what if it wasn't an equal number, like that, like 2.5, it wasn't that equal? Let's try a different example. So let's say I have 500 milliliters and it's infusing at, let's say, 135 milliliters per hour. So 135. So 500 divided by 135 gives me like 3.7037, So it gives me a number that is definitely not going to help me out with trying to figure out what the minutes are. Okay. So when you see that and you get some weird number, one of the things you probably want to do, and this is what I would recommend you do, is do one more conversion. Convert this next to minutes. And here's what's going to happen. So you're going to take your 500 times 60 divided by 135. So you're still going to get a decimal answer, but I'm going to show you a little trick here. So it says 222.22. Okay. So if we're doing like a time base and we're just trying to figure out how much time this is going to take, we really can ignore the decimal. Okay. And what I'm going to tell you to do is you can look at this and you can say, okay, first of all, we know that there are 60 minutes in an hour, right? So 2 hours would be 120 minutes. 3 hours would be 180 minutes. 4 hours would be 240 minutes. So we know that it's less than 4 hours. So what I'm going to do is I'm going to take my 180, right? So we know that's 3 hours. 222 minus 180 gives me 42.22. So if I was estimating this, I would just say 3 hours, 42 minutes. I don't think you're going to get a question like this. This was just to challenge you a little bit. If you struggled with it, that was intentional. I mean, this here. This is just a different scenario. Okay. This original, pretty much straightforward, probably something you would see. But this down here, the 135 milliliter, and then you have this odd number. I'm just giving you a strategy that if you ever get stuck or if it ever asks you, just know that you can reduce it more and then you can get a little bit more detail. There's another strategy for doing this using like fractions and stuff like that. We don't need to get into that though. Then you can be a little bit more specific and precise. All right. Let's go on to the next one. Now that I aggravated you with that one. So this says patient's going to receive 250 milliliters of Ringer's lactate over 4 hours. What would we set the rate on the infusion pump to? So again, if you're at North, South, or Boyce, it may not tell you milliliters per hour. You need to know that based off of the context. And what's the context? Doesn't say anything about drop tubing, drop rate, microtubing. None of that's listed there. So you have to assume that you're doing milliliters per hour. And the reason I say that you have to assume is because you can't just guess at the drop factor. The drop factor must be given to you, or you must know that you're dealing with microtubing. And then you know that that standard is 60 drops per milliliter. All right. So what am I going to do? I'm going to take my volume over my time. Now this, because I'm looking for milliliters per hour, I'm just going to reduce it. So I'm going to take 250 divided by 4, and I'm going to get an answer of 62.5 mil per hour. Now, students often ask me and they say, can you even plug that into the infusion pump? That's a good question, and I don't know. All I can tell you is that at Allegheny campus, they want you to round everything to the nearest 10th, with the exclusion being when you're doing basic unit metric to metric conversion, so like milligrams to grams, micrograms to milligrams, and when you're dealing with drops, okay, you round to the nearest whole drop. But when we have a number greater than 1, we round to the nearest 10th if necessary. And if we have a number less than 1, we round to the nearest 100th, again, if necessary. All right, last one here, another drop rate question. So the physician has ordered 500 cc's of dextrose 5% normal saline to be infused over 5 hours. If your tubing is labeled, so tubing tells you drop rate, 15 drops per milliliter, what will the flow rate be in drops per minute? Okay, so long way first, 500 cc. We can just go ahead and convert cc to ml because we know that's the same thing. Over 5 times your drop factor. Now, if you are converting hours to minutes at this step, it's fine. I'm just arranging it differently. There's no one right way. Okay. What did I say? 15 drops per milliliter. And then 60 minutes per hour. So we know we've set everything up right. We're left with drops per minute. Before I do any math, 500 times 15 divided by 5 divided by 60, and I get 25 drops per minute. The other thing I'll say about this particular question is that when we're looking at this one, you can do some things to kind of help create like a shorter process. So 500 milliliters over 5 hours, that's the same thing as 100 milliliters per hour, right? And then 100 milliliters per hour, 1 hour is 60 minutes times 15 drops per milliliter. 100 times 15 divided by 60, and we get the same answer, 25 drops per minute. The reason I do this is just because I know that some of you, that's what your process is. You're like, okay, I'm going to reduce this and then I'm going to do this. I wanted to show you the drawn out way, the long way, and then give you an alternative. The other alternative is you can multiply 5 times 60 and get 300. So 500 over 300 minutes times 15 divided by 60, and then you can get the same answer that way as well. So, all right. Any questions on any of these? Again, this is it's called Nursing 130 Additional Practice Problems. It's in the OneDrive folder. You'll see this marked up, the 23 spring. It'll be marked up with what I've just written here, so you'll be able to see it. If you want the blank one, it'll either say 16 fall Nursing 130 Additional Practice Problems, or it'll just say Nursing 130 Additional Practice Problems. All right, let me pull up another document here. This was emailed to me, and I thought these were some good review questions that would be good for focusing on flow rate type questions. This is in the Boyce folder, I believe, but or maybe it's North. But you can you guys are more than welcome to look at any of the other folders. You should be able to do all these things. So someone yeah, so I will upload these onto YouTube most likely tomorrow if I don't get to it tonight. But because I'm doing these reviews all day today, I usually don't have time to upload as well to YouTube, so you'll probably see it up tomorrow. But the Tuesday ones are already up there and ready to be reviewed. The folders are in the OneDrive share folder. So if you go to the OneDrive share, you'll see it'll say Allegheny, North, Boyce. There's a variety of folders within the shared folder. And again, if you click on the link where it says click here for practice tests, that's where that brings you. All right, so let me close out of this real quick. All right, so this again, I'm going to increase the size here. These are questions that were not mine, but were emailed to me. And I think they will give you another perspective on some of these labeling questions. This might be more geared towards 230, to be honest with you. Let me just see, because I know one of these is a good one for you guys. Oh, you know what? This is a good question that you'll see. I'll work through that first one, but let me just do this one real quick. So this question says you have a client weighing 165 pounds. The order is to administer a bolus of heparin. Thank you for sharing that link to everyone. Client weighs 165 pounds. And I just want to clarify, I'm under the impression that that you were sent the email, or it was posted on Blackboard, and it would have the link for the Zoom. It has the link for my YouTube page, and it has a link for the practice folder. So I apologize if for whatever reason you don't have that, but thank you for sharing that in the chat. I appreciate that. All right. All right, fair enough. Yeah. Okay, so client weighs 165 pounds. Order is to administer a bolus of heparin sodium IV. The hospital protocol is 80 units per kilogram. How many units will you administer? Label your answer appropriately. Okay, so when we see this, okay, first of all, it tells you what to do. But if you didn't know what to do, you're administering units. Now, the reason I'm saying this is fair game is because you have a question very similar to this, but it'll say milligrams per kilogram. Okay, so what this is considered a complex weight-based problem. Complex in that you have to convert the patient's weight in pounds to kilograms and then solve for the units, which is pretty straightforward. I'm going to show you the way that I think North Allegheny or North, South, and Boyce need to do it, and then I'll show you how I would do it. That should give us the same answer for Allegheny. But if you take your patient's weight, and we know we're converting pounds to kilograms initially, So 1 kilogram is 2.2 pounds. And then we would just multiply by the order, which is the 80 units per kilogram. And again, the benefit of doing dimensional analysis is we can see that we're left with what we're looking for, which is units. So I'm going to take my 80 times 165. And then divide by 2.2. And I'm going to get an answer of 6,000. So I would administer 6,000 units. Now there is, so if this was milligrams, it would be 6,000 milligrams. If this was micrograms, it'd be 6,000 micrograms. So units, you can interchange that. If you're doing later on, like next semester, when you get in the 3rd semester, 4th semester, you'll convert these units to milliliters based off of what's called a heparin protocol. So there'll be an additional step. If you're at Allegheny, what I usually, when you'll see, especially if you go through my reviews, I'll take the 165 divide by 2.2. And here it's not going to matter because it looks like it's going to be a whole number. And I'll get 75 kilograms. Then I would just multiply by the 80 units per kilogram. And then I get the same answer, 6,000 units. The reason I did it the long way is because the reason I did it the long way is because I know at North, this is the way that they've been taught. That you guys have been taught. It might, I'm assuming it's similar at Boyce and South. And so I wanted to make sure I address that. And the other thing is the reason I do it the 2 different ways as well. When we're dealing with adult patients, when we're going from pounds to kilograms, if you round the patient's weight to the nearest 10th at the beginning of the problem versus at the end, the answer comes out to the same. Okay. So that's why I do that. Now, when you get into pediatrics 3rd semester, then yeah, you need to pay attention to that. So sometimes it's helpful. So someone just asked if you need to show all the steps. I don't know if you need to show all the steps, but you do need to show your work on the test. So that's a good question for your lab instructor to ask what you need to show. I will say that if you end up having to remediate because you don't pass the test, it's helpful for whomever you're working with, whether that's me or someone else, when you're reviewing, and we can see like what your thought process was when you wrote it down. So if you just like you just typed it into your calculator, you know, did you just make a mistake on the calculator? Like you forgot a 0 or you added a 0, or did you completely set up your problem completely wrong? So the benefit of showing your work step by step is to that avail in the event that that you miss a question. Yep. Yeah, as long as you're getting the right answers, you can use whatever approach works for you. That's like I said, I'm not in charge of the approach. I just know that most of the instructors talk about dimensional analysis, even though some of the instructors have a hard time with dimensional analysis. So that's why I default to that. But yeah, you can do ratio proportion. You can do, you can create different formulas if you want. There's no one right way to get to the right answers. Just make sure that you're getting the right answer every single time. Okay. So this one you would set up the same way, convert the patient's weight in pounds to kilograms. So this should also be, I think, yeah, it's 80 kilograms. So 80 times 80 will give you 6,400 units. So this is just another question that is basically the same as the previous one. I was looking for here, like a flow rate question. Oh, this is a good one too, because it has extra information. All right, so remember, when we're talking about flow rate, what do we need? We need to know 2 things. I need to know a volume, and I need to know a time. Okay. Notice we don't say anything about mass. We don't say anything about grams, milligrams, micrograms, kilograms. I just need to know volume and I need to know time. Okay. So it says order Marum 1 gram in 100 milliliters, dextrose 5% water to infuse over 20 minutes. So immediately, because I already know, I don't need to worry about the 1 gram. I need to know about the volume and I need to know about the time. So what is my flow rate? I'm going to take 100 milliliters over 20 minutes, convert minutes to hours. And I think I'm going to get 300 milliliters per hour. Now, if you're like me and you say, okay, if it's 100 milliliters, 20 minutes, then in 40 minutes, it'll be 200 milliliters, 60 minutes, it'll be 300 milliliters, then we're doing the same thing, okay? But 300 milliliters per hour is what your answer would be for this question. And again, it's nice to see this too, because then we can eliminate, and you see that's extra information. So Marum is the medication. Do we care that the medication is in grams and that it's Marum? Absolutely. But as far as when we're calculating flow rate, I just care about volume over time. Correct. Yes. Flow rate is, if we're talking about flow rate, it's milliliters per hour. If we're talking about drop rate, it's drops per minute. Okay. All right. So you can see what the student did here and then asking for confirmation. So it says 1 liter. So 1 liter is what? That's the same thing as 1,000 milliliters. I'm just making that conversion right now. Is to run from 1000 to 1800, right? So what is that? That is a time, right? So 1000 to 1800. How many hours is that? So if this is 10 a.m. to 6 p.m. is 8 hours. You got it. Yeah, so I know sometimes I ask you rhetorical questions where I'm not expecting an answer. I just wanted to make sure you saw how we got to 8 hours, right? So this is what I always keep in mind. Like the typical 8-hour shift is what? 9 to 5. So if it gets bumped back an hour, 8 to 4. If it gets bumped up an hour, 10 to 6. And so anyways, 8 hours. So how she set this up is correct. 1,000 milliliters. I even think I got this question emailed to me too. Per 8 hours. And then I'm just going to reduce that 1,000 over 8 should be 125. Yeah. 125 milliliters per hour. I just want to see if there's anything else on here. I said I would work this one out at the I skipped number 3 just because it's a repeat of this up here. You just convert the patient's weight in pounds to kilograms. I think you can do that. This one up here, I'll show you this if you want to just kind of tune out for a second. If this is not something you want to look at, you'll see this next semester. I don't think you're going to see this semester, but this is a multi-step question and involves patient's weight plus converting between the metric system and then converting from a different rate to another rate, meaning we're going to go from the rate currently is 10 micrograms per kilogram per minute, and we're going to convert that to milliliters per hour. So I'm going to show you how to do that. So we're going to start off with the patient's weight. I always say it's a good idea to start off with that anyways, because it helps to reduce or helps to get rid of a unit that can sometimes drive you nuts. Okay. So before I do anything, I get rid of that kilograms. That way I'm just dealing with micrograms per minute. Again, I'm going to show you the dimensional analysis way, and then I'll show you how I would chop it up if you don't like doing it this way. So right now, and if you pay attention and listen to how I talk about this, right now, the units we're in after I do these 2 steps without doing any math, the units we're left in is micrograms per minute. We know we're working towards milliliters per hour. If you didn't know we were working towards milliliters per hour, when it told you to calculate the flow rate and it didn't give you any sort of tubing information, that's how you know you're working towards milliliters per hour. So there's a couple things you can do at this point. You could go ahead and convert minutes to hours. If you want to do that, if you want to wait, that's perfectly fine. But before we move on anywhere, I'm going to recommend that just go ahead and do that and convert your minutes to hours. The reason being is because it's the next seemingly logical step, because you know you're working towards per hour. You may not know until you look back at the question what you're going to do with this micrograms. So the next thing it tells you you're available is the 250 milligrams in 250 milliliters. Okay. So I need those two pieces of information in order to convert milligrams or micrograms to milliliters. But the problem is I have micrograms listed in my order and I have milligrams listed in my available. So I need to make a conversion. Now, instead of complicating things even more, I would say make that conversion now, going from micrograms to milligrams. And then you should know that 1 milligram is 1,000 micrograms, or that there's 1,000 micrograms in 1 milligram. Then we're going to take our 250 milligrams. And then we're going to take our 250 milliliters, which is just one, right? Because they cancel each other out. And then I'm going to double check my work before I do any kind of math. Micrograms cancel out. Hours I want to keep, so we'll leave that circled. Milligrams cancel out. And what am I left with? Milliliters per hour. So what am I going to do? I'm going to take 60 times 10 times 60 times 250, which you don't necessarily have to do. Divide by 1,000. Divide by 250. And you should get 36 milliliters. Sorry. Hold on one second. My screen is slowing down here. So I should get 36 milliliters. See if I can get this to turn back on. That's interesting. All right, well, that's supposed to be 36 milliliters. For some reason, my pen stopped responding. All right, so 36 milliliters per hour. The alternative way, I'm going to see if I can get this to kick back on. I might need to unplug. Oh, there we go. Nope, still. Sorry. There we go. Don't you love technology when it's working for you? Okay. So come back here, 36 milliliters per hour. Then I'm going to come down here and I'm going to show you an alternative way. If I'm doing this at Allegheny campus, I would take my 60 kilograms times my 10 micrograms kilogram minutes. So I'm still kind of setting this up initially, but then I would get 6,000, sorry. So 60 times 10. I was right, 600. I don't know what I'm thinking. 600 micrograms per minute. So I would do this in steps. Then I would convert minutes to hours. So if you're looking at this, you're like, I don't like that, then that's fine. Don't do what I'm doing. You get 36,000 micrograms per hour. Then I would convert micrograms to milligrams. So you could just move your decimal point over or if it's good to review. And now I'm in 36 milligrams per hour. And then I would just multiply by that factor, the 250 mil per 250 milligram. So you'll see if you go through some of my old, like my reviews, and then this is going to equal the same thing, the 36 milliliters per hour. If you go through some of my old reviews or see how I've worked things out, you see all these equals. I just chop up the dimensional analysis, but some of your instructors want you to write it all like long. And I think, like they said, that's more for North, South, and Boyce. The feedback I've had from Allegheny campus is that they don't really have a specific way they want you to do it. They just want to make sure you're getting the right answers and that you're showing some sort of work, so that way they know you're not just guessing on your calculator. This is how I've interpreted that. So if you're ever wondering, like, why are they making me show my work? It's probably because of that. All right, I'm going to close this out just so if anyone wants to access it, it'll be there. And then someone asked me to pull up the 130 that I updated the review. So it'll say 23 spring is the most updated. Oops, I opened the wrong thing. 23 spring is the most updated version in the OneDrive folder. And then I'll just show you when this opens up. There we go. And then someone asked about the updated conversions. So if you're at Allegheny campus, you need to know up to these. Okay. But if you're at North, South, Boyce, you're going to want to know cup, pint, and quart. And I'm sure you already know that at this point. Also, for Allegheny students, when you do your NCLEX or you do your ATI, it's going to be helpful that you know the cup, pint, and quart anyways. So you might as well put that in there, and or at least know what those are. All right. So
can I ask why they do that?
Ask why, who does what?
Oh, why like Allegheny only has like up to the like 1 hour, but when Boyce has the cup, pint, quart too?
Yeah, I don't know.
I just figured I'd ask
it's a good question.
Like, I wonder, like, is there some kind of weird logic about that?
No, some of it is so like when I took over writing the tests for Allegheny campus several years ago, probably over 10 years ago. And then what I did is I just went off of what was previously put together, and then I added some questions, and then I was asked to add some questions that I wasn't quite sure what they wanted. One of those being like the fluid intake questions. The fluid intake questions that you know, North, South, and Boyce see are these right here, where you're calculating like the juice, the milk, and then that's where knowing pints, cups, and all that kind of stuff comes in handy. I also assume that you'll see that on your NCLEX. But at Allegheny campus, I interpreted that as fluid replacement questions, which is this here. So this is this question that I have highlighted here. Allegheny, or I'm sorry, Boyce, North, and South do not have that type of question. But I think it's a similar format in that you are calculating a replacement volume. So there's some things that are just a little bit different between the campuses, but for the most part, you're being quizzed and asked the same thing. And I think over time, this is going to start to integrate a little bit more, especially now that I know. And then that I also know that, you know, I'm getting asked more to do these reviews for North, Boyce, and South. This is recent, me working with the other campuses. So that's why it's still like you know, it's in process as far as making some updates and things. But I personally haven't updated any of the practice tests or anything like that since at least 2016. And that's just because I haven't been asked to do so, other than incorporating questions for the other campuses that I just didn't have practice questions for. So
Right.
that's the
No, I
long
can,
answer of your
I can tell
question.
you, at least for the dosage calc, it doesn't, well, at least like 110.
Mhm.
Okay, it doesn't really, I don't think it goes up that far on 110 with that one, but later on in the semester during our lecture and stuff like that, we get into those 2 questions.
Okay. Okay. Yeah, and I know like that's the other thing is, yeah, you know, some of these things you might see at different points in semesters, even between the different campuses. So that could play a part too. I know that when you get in the third semester, a lot of times you're being asked about like heparin protocols and you haven't even done that unit yet. So but anyways, that's why these exist. So somebody asked about number of questions. So for all campuses, it's the same as the 110, 25 questions, 1 hour to complete. I think the difference is all of you probably are at this point, or everyone should be paper tests. I don't think anyone's doing a Blackboard test. Yeah, someone asked about, so yeah, everything that I worked on is already uploaded. It's already in the folders. You just have to look around for it because, like I said, that was the one that I was doing, like the weight-based one was, I think, in North or Boyce or South. So if you're wondering, like anything that I've shown you is available to you to look at on the OneDrive folder. So. All right. Well, I have I'll be meeting to discuss 1:30 again this afternoon at 3:45. If you have any questions, feel free to join me then, or you can email me if you have any additional questions. I'll put my email in the chat if you don't have it. And if you came in late and you didn't put it in yet, please put your name and campus. That way I can record you as being here. And if I don't hear from you, good luck on your test next week.